Good morning. This is my presentation of for Engineering Computation course. This is my final project. The case is a numerical method for engineering case, which should be implemented in programming language such as Python or JavaScript. I'm using Python, by the way, and solving this using the computational thinking framework. Okay. My chosen topic is sensor predictive model using polynomial regression with two cases, two sensor, field stick and x-load. The problem is current calculation of sensor prediction using step function is not smooth, so the prediction is not good. So how to make smooth model? Okay. Okay, let's start it. Okay. Okay, this presentation has four parts. The main report using the AI5 framework. Then the rest is using stage 1, stage 2, stage 3 using computational framework. Let's consider it as the AI is the why and what. This is the why and what, and this is how we do it. This is like the theory, the math behind it, the statistical method. This is the coding, make one coding to another, and the last one is how to make AI assistant. Okay, this is my report. Okay. The entire presentation is working proof of how thinking framework can be helpful in explore things, especially in complex system. Because when we have complex system, there are so many things in our brains simultaneously, parallel, is jump from one point to another. So we need good framework to do it, and this is really helpful actually. Okay. I also put this report on the website. Okay, let's see the website. Okay, this is my blog. Okay, I have it all here. All right. We use to AI first on local host to try everything, and on server, campus server. Okay. Alright, let's skim the presentation first. What's in there? I make a high quality presentation, but most important is the contents, the material, not the looks. Okay, let's do it one by one, pages by pages. Okay, the project title AI assisted sensor predictive model using polynomial regression, and my name is 𝐏𝐑𝐄𝐒𝐄𝐍, Department of Mechanical Engineering, Faculty of Engineering, University of Indonesia. Actually, the language should be in Indonesian language, but I want to choose English because I want broader audience beyond the local context. And I also have a foreign friend using English. I want to be a good friend, so I use it English. Alright, the abstracts. Well, it's too long. Don't read. It has three stages: building smooth predictive models, refining to particular Python script. I use the Python script every day. The result I use that for daily basis in my office. Then I write I implement AI assistant, and all three in computational thinking frameworks. Okay, how do I do that? I make rules, embedded rules within the script. Okay, I would like to comply the AI5 evaluation criteria as much as possible. This is my summary of the AI5 framework. No, not my summary. The professor make the AI framework, and I write it down in infographics. Okay. Everything starts from awareness. So this is me and God. I get it by higher purpose. As a Muslim, I'm a hamba Allah. And the second is as a human being. I'm an employee. I'm a student. What do I need? Why do I live here? Yeah, this is not existential question, but rather than is my goal. I want to be able to handle complex system. So all I've got is skills, executions. Sometimes I read books, deep, sometimes too deep, exploration. But I need further capability. And this project is complex. It has statistic, numerical method, engineering case, AI assistant, and making presentation using good looking presentation. It has to be good. When you work somewhere, you meet client, it has to be good, or you lose. So this has to be good. The presentation has to be good. The thing is connecting all the orchestrating all the points is exhausting. So I need to be able to handle this complex stuff, connecting the dots, etc. Okay. What's my intentions? Predictive models for what I already used in my office, a few level and as well as sensors. Okay, I have permission for my project manager. Okay, it's combining numerical method with Python implementations. Okay, this is also like too long, right? This is the sensor. I draw it with myself from the manual books. Okay, this is typo here. Okay. Now the composition. We have everything. This is the numerical method parts. Actually, it's statistical method, but we cannot inverse matrix using manual. It's actually numerical method, and a lot of things, a few things, also numerical method. Then current environment, and last is AI systems. Okay. This is also too long. Alright. The statistical part, the polynomial regression, is settled. Also coding, you can use ChatGPT or Googling, and you can get polynomial regression, or maybe different with mine, but the knowledge is already settled. What remains is AI assisted automations. This is new frontier, and we are going to focus here. Okay. This also you can skip this. This is actually from my blog. Okay, let's see my blog. Alright. I make this blog years ago. Someone make a lot of article series. It started from one simple articles, but it grow month after month after month. Okay, this is the regression part. I use it for daily basis in my office, right? Instead of making new project, this is settled, so I use this for my final project, so I can focus on the AI assistant. Okay, let's get back to the presentation. Okay, look here, even the formula looks analytical, it's a bunch of equation, but the equations are computed numerically. Okay, the session already proven, as I said. Okay, this is the computing part. Let's skip. Okay, this is operational. Let's skip. Okay. This is the flowchart of those three. This we have prediction model, coding, AI Einstein, all in the AI5 framework, and this is the flowchart. This is the algorithm part. We can go deep later in the presentation has 4 parts, right? Stage 1, stage 2, stage 3. This one has its own presentation. Stage 2 has its own presentation on also the stage 3. Right. We have performance. Okay. Results. Well, we have success and also failure. I openly say where do I fail, where do I make improvement. Okay. Okay, we can read this. I will put this letter in the blog so you can access this presentation. No need to read them all in our video. Okay. This is my main measures. Actually, I haven't made quantitative measures. I make qualitative measures. How do I define how this AI assistant works or not? I make 2 qualitative measures. First, how well the AI obey the scripting template. So it has to be the same with the given knowledge. And the second is how flexible the AI when facing dataset variability. So like in the field, we have calibration data, give it to the admin, maybe data analyst, maybe engineering, and normally we use Excel. And or validate with Python, give visualization. We want to automate it with AI. So the idea is we give raw data to the chat prompt. So we have variability. We have variable data set, and the prompt should generate the chart, the visualization, using Python, of course. Not just that, the chart should be able to define different degree. Like I want just cubic, but maybe another day I want like 6 degree polynomial. It's very rare, but hypothetically we need to test the AI stand. Okay, I found this the hardest part of implementation. Reliable knowledge. It's very hard to make good knowledge, but I finally find okay, let's using one simple script. But for one simple script, it's still very hard to make good rules, good embedding rules. Okay, and we have like different environment like localhost, server, and so on and so on. This is going to be the hard part in implementation. Alright, so what's the problem? The problem is when you work somewhere, making calibration is not, it's swelly, but it's doable. Any mechanics can do that. Making application is, any software development people can do that, but it's rare that you have people who can do both. So usually the admin is using just Excel, but when they have to analyze the data, it's going to be it's not a cheap labor. It's not a cheap labor anymore, especially when the labor have to use Python, have to understand. You have to hire someone with skills, not just data, but use admin, communication, and blah, and field operation and stuff. So the idea is, if we can make AI assistant, we can reduce this cheap labor. So the data can go directly from mechanics, put it in an application, and it just work without the need of analyzing and blah 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 blah. Okay, but my result is not ready for production. It's very early. I don't want to use this result in my office. The office still need data analysis. We still need somebody who knows Excel, who knows Python analyze. Oh, this is still typo. Okay. Okay, we have two environment. The task is actually using campus server, but it has, I could be wrong, but there is good indication it has no contamination, because my test is 100 failed in campus server, but in isolated environment in my localhost 95% good response. So this is the mantra. It works in my computer. But this is actually like sarcasm. But if it works in my computer and it doesn't works in shared server, that means I fail. Okay. Okay, the other factors, textualization, factorization. Actually, there are more. Tokenization, textualization, factorization. Okay. Yes, that's great methodology. Can this report can be replicated? It has further works. It's not finished yet, and it has potential, like I said. Okay. These are the things. Computational thinking is iterative process. I already decomposed into prediction model, coding refinement, and AI assistant, but each steps has hierarchical decomposition. So prediction model also has its own decomposition, its own algorithm, and so maybe the subsystem have its own decomposition. So it's like the process. And remember that between its step decomposition, pattern recognition, section, sometimes it's blurry. So we have to go back. Sometimes in abstraction we have to go back to decomposition, refine, and make a pattern recognition again, and go to the abstraction again. So this is an iterative process. Okay, I have made a good infographic here. Now the conclusion. Yeah, it works, but it also fails in shared server. And it's not just the project. I use this project to learn the AI5 framework, also computational thinking principles, and the integration is work so good. Okay, I think that's all. I use from okay, this is my own repository. Let's see how it goes. Okay. I also use Google Notebook. So many code here, so it's take a lot of effort. Okay, I think that's all. Now that's all for the main presentation. Now we are going to jump to first stage, the prediction model. This is the detail. Okay, statistic is established, and I have already started this polynomial regression like 5 years ago. Refine every year, self-learning. This is the decomposition part. Remember that I refine every year, so it has more and more decomposition. For the last 2 years, I have applied this in my office for view level, for sensor, evaluate with actual data, and then yeah, there are a lot of things here. This is the algorithm. I make spreadsheet pattern. Using this fundamentally. Using gram matrix. Okay, I know gram matrix. I use spreadsheet, tabular spreadsheet. Actually, the first time I use this, is I don't use Python at all. I make the model using spreadsheet for just linear square. Then I make enhance the model using gram matrix, so I can have more coefficients. Then I make the Python very manual, no libraries, just showing the statistical properties based on this spreadsheet. Then as a hobbyist, I try in other different languages like Julia, GNU, R. I need to know if I do it right. I need to know if the calculation between Excel and different programming language is consistent. So check and recheck. I even check with PSPP, the open source counterpart of SPSS. Okay, I don't know if this worked right, but I also try alternative series, but I dropped them. I don't really understand about this, so I use normal polynomial, and then I put them all in my blog using Hugo static site generator. This is passwords. This password is already set. Okay, you can read in my blog. Now we have finished. Yes, we can start to the next stage. Stage 2 is coding refinement. Actually, coding refinement is in the blog. I already make the coding refinement. It's parallel with the statistic, so, but for decomposition, for easy to read, I spread them in different states. Alright, this is like, you can read yourself. This is the refinement. This is the historical, what I really do. I use extreme programming from scratch, not really using methodology, so because this is just a simple script. Using methodology is overkill, so I use extreme programming. Yeah, it's well documented. So use Jupyter Notebook. Okay, alright, this is the film. Let's see how it goes. This is the film, right? This is the you can see. Okay. See them all here, and we can run the script. Python. That's it. So simple, nothing special. I have another works far more complex than this, so this is this simple. This is just showing the coefficient for different degree, and also calculate the R square. Okay, I always start with simple script, then refactor to class base for daily basis. This is good for the left is good for starting, but for real world, when you have to refine the script, please use object-oriented class base. It's far more simpler. Okay, I also use different library, like for the same matrix multiplication pattern, you can use different kind of library. Even from the same NumPy, they have linear algebra, polyfit, extra. Okay, and I try them all. more. Not just NumPy, but also other library as well. And this is the result. I also try different statistical properties. So I'm not just exploring the Python, but also the statistical properties. So this is the last part. I have used this for the last maybe 1.5 years. The same script. Not really refactor, because for my office it's clear that it only need 3 degree, so I hard coded the 3 degree here. This is why we need to make refine this letter in AI optimized version. This is really not adequate for AI. We need to refine this letter, but this is how it works. We have CSV, we have main. This is the script entry point, and this is the class. Process it. The process is only using plot and draw. We will have more process later, but for daily usage, we can we only need this plot and draw and print properties, actually, and print properties. Oh, that's right. Okay. We have seen flowchart. Okay, we have seen flowchart here. This is the flowchart of how I do the Python refinement, but not the flowchart of the Python itself. For the project itself, for every project I have a habit for making system design using UML or BPMN and maybe other infographics. For this simple project, UML is enough, sequence diagram is enough. Oh, this is not sequence diagram, this is class diagram. Okay, this is a typo. Again, this is a typo, class diagram. This is activity diagram. It looks exactly like flowcharts, but it's different. For this project, it's exactly the same with the flowchart. Flowchart is exactly the same with activity diagram, but for real case, activity diagram is more like examining the behavior, not the sequence. Then we have data flow. This is not data flow diagram. It's simplified. We cannot formalize this as data flow. Any IT people would be like, well, this is not data flow diagram. But yeah, this is the simplified. Okay, the purpose is to differ diagram for the whole algorithm design. So what are the things, what artifact required for this project? Okay, I also for actual business process, like in a factory, we would need BPMN. What is BPMN? Okay, this is BPMN. When you have different people interacting with each other, we have to make the lane here. So like here we have customer, hey, please install sensor and give it to the mechanics or technical operations request form. Then the mechanics, the field operator install the sensor in vehicle, then get the data calibration and submit to the admin. I would like to say data analysis, but data analysis is using dashboard analysis. We have the smart people in my office, but it's not doing this. This is just actually it's me that doing this in my office. So I put my own title as data processing. Data processing, I clean the tabulated data. Sometimes the mechanics have no time to make pretty neat spaces, so I clean the data. Sometimes the data is in hexadecimal, so I have to convert to integer and etc. Then I calculate with, so I have to calculate polynomial using spreadsheet. Tabulate using spreadsheet, nice, pretty spreadsheet, and also Python spreadsheet for visualization. Then compare the two. Then I validate, make decision. Most of the time quadratic is my choice, most of the time, but I have to be careful. I have to see every time. This is a field operation, anything could go wrong. Sometimes the chart is not the visualization is not as expected, so we already know that, oh, you install it a wrong way, please give me the photo of your installment. So this is not just making polynomial, but also examining the result and comparing with the common result. Then I give it to put in application, so in database. And then I check the visual application in the application, show the dashboard of specific sensor in specific vehicle. If the visual is valid, I talk back to the mechanics. Oh, our data is valid. You can go home to Jakarta. You can go home, and then the field operators can tell the customer that the installment is complete. It's usually the customer then check the dashboard here again, but I don't need to put it here. Our job is finished here. This is the actual data for view level. It's like this. This is the Excel part, and this is the Python part. This is for the weight, to measure weight of the box. As you can see, this is we have hexadecimal. We have to put it to float, to fraction, not just integer. Then we have this polynomial. The actual data that needed is actually just start, middle, and end. So here is empty, full, and half full. Too many calibration, over calibration is not good. But why do we have this so many data? Because it's easier for the field operator this way. I don't need so many data. 7 is enough. But for the operator, it's easier to put the data one by one, step by step. We can use forklift and put all the data in there, but this is our consideration is better this way. We have finished our data with engineering case. Not a really engineering case. This is just calculating polynomial, but using the actual data. Now the main part. The main part is stage 3. The AI system. Wow, this is the. Wow, it's gonna be great. This, like you saw, this is the computational thinking. First, we have to decompose. We have pattern recognition, abstraction, algorithm. This is the flow chart. can read it yourself in detail. Okay, this is the main part. Okay, handling beautiful augmented, handling knowledge. Okay, first we have to know the difference between a pre-trained training model and context window, because we have to deal with all of this. We have to know this. Okay, this context windows is basically like system prompts, and this is the model. But context windows isn't just context prompt. It has attachment. It has RG chunks from knowledge. It has the response from the prompt itself. Sometimes the system have developer prompt, user prompt, and etc. Okay, the thing with the context window, everything from user prompt is tokenized. We have tokenization in system level. So when you said, do you have hypothetical docs, it always tokenization. Tokenization is the sequence, so the AI understand. It's always text. So when you give image to Gemini, ChatGPT or DeepSeek, they use different model and give the feedback as text and put it in a text as another context window. Okay, we know about tokenization because every day we chat, we use tokenization, but there is other thing. This is factorization. Somebody who might read or watch a lot of YouTube about LLM must know factorization. But what is factorization actually? Factorization is not just knowing the sequence. The sequence is done here in tokenization, but factorization, they understand the semantic. Like king or queen is totally different word, but it has a very similar context. So when factorization is expensive, but we need factorization to for RG chunks, so we can use it over and over again without too many tokenization. We can reuse. So we need factorization, but the thing is, factorization is heavy computation. So we need other things here. Do not put heavy knowledge in factorization. In fact, do not put heavy knowledge in prompt. So in prompt, if the model is small, we have to make the AI understand. How do we make the AI understand? So put all the image in textual, describing in text. Put all the structure in markdown, structured documents. Put all the equation. We're engineer here, right? We have a lot of equation for daily basis. So we put our equation in text put the equation in 𝐌𝐀𝐿 or LaTeX. How about coding? Coding, Python, JavaScript, and etc. is already text. Source code is already text. So leave it that way. And there are other things. Don't use diagram like arrow and etc. It's already text, but this will confuse the AI. So use plain OML instead, or Mermaid. That's good. Okay. How about other text? Okay. XML is heavily structured format. This is why we cannot put Inkscape document like SVG directly into the prompt, because SVG is XML. It's structured document. It's a heavily structured document. So please avoid that. How about LaTeX? LaTeX is complex, right? Yes. LaTeX is not simple, but we have no other alternative. So all we have is LaTeX. Okay. We are engineers. We need engineering drawings, and unfortunately, no engineering drawing representation in text yet. If you want to make a thesis for making engineering drawing representation for knowledge, for textualization, that would be good. Maybe I will use it. Okay, this is our new engineering challenge, textualization. Right, let's continue the testing phase. Okay, I test with different kind of testing. At first, I don't know what to test. Start from the most of the time I start from the I don't know about this thing, so I just do it. So I put my LaTeX document, math problem, and it works. And then I continue to use my differential problem in Markdown. I have PDF, custom made PDF. I made it myself. It's full of integrals, and the AI can do with that. Then I have responsibility to use this to make a project for this engineering computational engineering computation course. So I choose polynomial project. So this is my polynomial AI workflow. This is monolithic. Okay, I start from big chunks like 700 kilobytes of knowledge. I put all the knowledge from my block. I merge from the content of my polynomial block here. It's about maybe 25 articles and merge into one, and it doesn't work so well. It has window context limitation. The knowledge is truncated. It can read, but it's truncated. It cannot be perfect. Then I try atomic. This means for others this means just one simple script Python, but I put embedded rules inside the script Python and placeholder, so the AI know what to obey and know what flexible can be changed, and what have to be remain. Okay, and then for all of this I test in both environment, in my computer, localhost, and also in campus server. Okay. And the testing, it is I different later, not the design from the start, but then I make a lot of notes and I can define. What I test is the model capacity. This is why I using different kind of model: Mistral, 𝐏𝐫 1, 4, and 12 billion, and it looks, yeah, the reasoning degree with more models. And script design, I use different script design. The script design I use in my office is simply not optimized for the AI, so I have to refine. Then I change, then I test and make a trial in different environment, localhost and campus. Alright, this is the result. Yeah, I try to pass the exam on the other class, so I do homework. I do my homework. I read the crazy book, and I write the problem set manually, and I ask to Gemini. And then please make the solution for me and make the lattice for me. So I have 2 documents: problem set 1, 2, 3, and also make a summary for trigonometry. Then I test the AI if its model no. Okay, and its model no, and it doesn't work in small model, but it works in 𝐏𝐫 12 billion. Exactly the same. But it got me thinking: does it really calculate or just rewrite the given lattice context? So I change for different temperatures for Newton law cooling, and it works. I compare it with the DeepSeek, Gemini, ChatGPT, and it has the same exact result. So it works. Okay, but it not always works, right? It not always works. Sometimes it works, sometimes it's not. You have so many trials. We need to be stable. Stability is important. We cannot use in production. I can ask my mechanic to prompt if the answer is not stable. Okay, and then this is also, no, this is not explanation. It is mathematical, also mathematical course. We have determinant statics problem. I do my homework as usual, and it works. Same result, same structure, but I cannot go further because my homework is too few, just a few documents. I need a huge document to test the AI. Okay, so I decide to use my past work, my article series, my Polynomial Regression series, 25 articles. Oh, okay. This is the definition problems in campus server. It seems to ignore the knowledge, but I finally know why. We can find out the reason behind this error. Okay, this is the back to the statistic. Okay, we have 25 𝐏𝐫 pages here, and I merged them. look at the number of the lines. It's more than 28,000 lines. Not just the text, but I also put the whole code here. Julia, Python, GNU-R, and but I cannot put image here. Like I said, it has to be text only. Okay, let's see the result. The result, well, improving in localhost, improving, but somehow the knowledge is truncated in localhost. In localhost is truncated. When I put in campus server, there's even worse. It doesn't read the knowledge at all. I have for this result, for this knowledge, I choose different strategy. Separated 25 files, 25 files merged, and they are setting in Open Web UI. I try different settings, and well, no luck. So I decide to use simple script, atomic small file, then testing in an isolated environment like localhost, my notebook. Okay, the result, yeah, the result is better after tweaking some tweak, but partially complete, never complete result of the script. It's, you can see here, it's 1-to-1. It's exactly the same here and here, but never the whole runnable script. Well, what good is it, a Python script, if it doesn't run? Okay, so to investigate the variability, I need to narrow for just one script. Okay, this is the one script using 𝐏𝐫. I actually test in every model, but my focus in for 𝐏𝐫 12 billion, because the campus server is also using 𝐏𝐫 12 billion. I replicate this in my localhost. I use this. I have 7. I have 9 tests actually, but only 5 tests from the start, from the consistent test. The 4 tests is only the last 4 tests having another test set, but the original test is only 5. First is choose data set. Okay, ask the AI to replace data set with whatever you want, and this is the expected result. And then add new function. How if the change of the Python script change, and this is the expected. Okay, and then again the structure, making modules. It's going to be harder for the AI. Okay, and the fourth is, does it obey the rules? Okay, if it not numpy, the AI should refuse. Okay. How about breaking the rules, override the rules, but intentionally, like adding our own custom script and so on. Okay, this is the test. Okay, first we make to dump our previous Python script and make AI optimized Python script. I won't tell you how to do it here. It won't be too long. The presentation will be too long. So this is the result. Okay, it will be injected with rules. The rules is just comment in the script in the very beginning. The rules is like this. I changed this over and over like 8 times. I stopped to change the rules because I see different issue. So optimizing in rules is no more performance. We have to change. We have to face the hierarchy issue, level issue, or maybe a contamination, and etc. Okay, I start from simple rules. The rules is from very simple. Then I adding and maybe removing, define. Okay, and this is the results. Unfortunately, I haven't. In my first test, I don't write, so I start from the second test, the third, fourth, the fifth is skip. Skip is so bad that I don't need to write it here. So I rewrite the rules all over again, the whole rules, and we get this and this, and we had the 8 for the server. Oh, another typo here. Okay, the first is not good, not plotting. This is not no problem. Not really a result. And the third test, not outputting. No code at all. This is have full code, partial code, not giving the full code. And the rest looks good. And it's the result. Okay, we can see the result here. Sorry, here's the result. Here the result. Here the result. You can run this. Running. Okay, something like this. Okay. Okay, let's skip the result. The result and the seventh result is 100%. It's 100% good. But why do I say I only have 95% good? Because I add 4 more tests. The 4 more tests is also good, but the last 2 is not perfect. So I rate just only 95%. Alright, here's the trick. From the 6th and 7th, I use this. Sorry, I have to go. Alright, from 9 and 6, I change the chunk size. Why does it fail in the first place? Because it used the default setting from Open Web UI. But after I change to this, actually it's 8000, not 800. After I change to this, 100%, 95%. And now the last trial on campus server. the 𝐏𝐵 server. Okay, this doesn't seem so good. This is not the problem of the server. If it's failed, it means I'm not success. I'm not success. I failed to complete the task because the task is to succeed in campus server. Okay. Okay. The trial have recursive never ending script. It's very long. Let's see the assessment here. Okay, give you the files. Okay. Here's the files. Okay. Do we start here? Showing the rules, the class, but it's never ending. Look at it. Never ending. And the worst thing is if we reply if we do it in other chat, the result is consistent for the same prompt. So I have maybe little issue, maybe contamination, I don't know. I have to investigate. How do I investigate? The time is running out. It's already like a final term session here, but I have to stop here. So yeah, this is all I've got. I hope that someone does it better, so I can prove that I'm wrong. I hope that someone can prove that the server is actually okay, and this is just maybe just my methodology is wrong. So I think this is it. Let's go back. This is my presentation. I love this, and see you on the maybe other presentation. I really happy that I make this presentation because we can utilize this framework, utilize the whole methodology here, and for the real engineering case, I'm thinking of pendulum for digital twin. Pendulum, you can start like from theoretical, using Newtonian, Lagrangian, Hamiltonian, and make like a system, or in computers, and then we can put a model, put a sensor, and make some digital model there, and all doing it in this framework. And there are other things as well. There are things can be done with this framework, but this is beyond this presentation. Okay, thank you very much. See you next time.